I'm not a physicist, so this sounds complicated. You have laser beams and magnetic fields. Why go to citizen scientists who are not, I mean, you're the physics expert.
Yes.
So why do we go to the citizen scientists?
I mean, that's I guess one of our things that we do in Science at Home, that we have also already other good experiences with citizen science experiments, and also outside of Science at Home. I mean, there are a lot of complex problems that were solved together with the citizens. And we started, that was 2 years ago, we started with a collaboration with some theorists to investigate how are these, well, we know that there are some solutions how we produce cold cloud of atoms. We know that this is a complex landscape, so if you imagine it as a landscape, there are some certain spaces where you can make atoms cold, and if these positions in this landscape are basically corresponding to how these traps are formed or these cups are formed. And we don't know exactly how this landscape looks, so we know that there are certain peaks where we can produce cold atoms, but we don't know the whole landscape, and it's huge. And we needed to find ways to search in this landscape. And it turned out that citizen scientists, if they get the right interface, or if they get the right tool to do things, to solve problems, that they are really efficient, which we saw also in the quantum moves game, and which we thought we could maybe also see with our particular problem here.
Yeah, and I guess that's also then where my social science interest then comes in.
Exactly. So
that my interest is here, as you said, we know that citizen scientists in former projects have turned out to be very good at solving these problems. And then my question is, well, how come? Why is it that they can be so good at solving this? And that's a big question in social science, is that how can we optimize problem solving? We solve problems all the time in business, when you're a student in school, when you're teaching, when you're trying to explain things, we always try to solve a problem. And here we saw an opportunity to, in a controlled environment, have people trying to solve a problem that is really, really difficult, as you say. Mm-hmm. There are millions of different ways that you can try to approach this problem, while the studies that we usually do in the lab.
Yes, exactly. What are you usually doing?
Yeah, so in the lab we would maybe have, we have a social science lab. We might have 20 people showing up, and they get exposed to some problem on a computer, and they click on stuff, and then we learn about how people solve problems. But these problems are usually very, very simple. It's like literally clicking on this image or clicking on that image.
So you have two images, which...
Yeah, and then you either do the same or you do something different. So you have like really simple and artificial problems. So when I then look at what people have done, I can't use that in the real world. I mean, people clicked more on this than on something else. That's not gonna help me. I want to find out how real problem solving goes on. And here I had an opportunity to look at a very, very high dimensional, very difficult, complicated problem, but still in a controlled way.